Welcome to the session on graded exercise of circuit simulation lab. The graded exercise is a program on RCS circuit. Uh, the contents of this session are like this: theory part related to RC circuit, then MATLAB script for the given exercise, then the result obtained after the execution of the script. Then we will also be seeing few multiple choice questions. So the given graded exercise is like this. For the figure shown, the input voltage is a rectangular pulse with an amplitude of 5 volts and a width of zero point 0.5 seconds. C is equal to 10 microfarads and R is equal to 1000 kilo ohms. Write a program and simulate to plot the output voltage V0 of t from 0 seconds and it should end at 1 second. So they have given the circuit also. The circuit is a series RC circuit. Let's see a multiple choice question on RC circuit. What do you mean by an RC circuit? So there are four options. The first one is like this. A circuit with both a resistor R and a capacitor C. A resistor R and a capacitor C. Third answer given answer is voltage and fourth one is current. So which is the right answer? Here it is a circuit with both resistor and a capacitor, right? RC circuit consists of both resistor and capacitor. So the right answer is A. Okay, now we shall see the expression for the output voltage during charging period and also during discharging period. When the capacitor is charging, the circuit can be written as shown on the screen. So here we have shown the voltage source. So now when we apply Kirchhoff's current law to this circuit, we get the equation as C dV0 by dt plus V0 of t minus Vs by R is equal to 0. Because the current flowing through the capacitor can be written as C dV0 by dt and the current flowing through resistor can be written as V0 of t minus Vs, the potential difference across resistor, divided by R, and that becomes equal to 0. See what happens here in RC circuit is when the supply voltage is greater than the voltage across capacitor, the capacitor will keep charging, and when this voltage, supply voltage, becomes less than the voltage across the capacitor, then it starts discharging. So here the circuit shown is for it is during the charging period. So we get the equation like this, and when we simplify this equation, we are going to get it as V0 of t is equal to Vs into 1 minus e to the power of minus t by Rc. When the capacitor starts discharging, we can write the circuit like this, and we can again apply the Kirchhoff's current law to this circuit. So here again we are taking the current flowing through capacitor C dV0 by dt because that is the expression for current flowing through capacitor. So current flowing through capacitor plus the current flowing through resistor is equal to 0. So C dV0 by dt plus V0 of t by R is equal to 0. So again when we simplify this expression, we are going to get it as V0 of t is equal to Vs e to the power of minus t by Rc. We shall see a multiple choice question again. In an AC circuit with R and C in series, voltage across R and C are 180 degree out of phase. The voltage across R lags the voltage across C by 90 degree. The voltage across R leads the voltage across C by 90 degree. Voltage across R and C are in phase. So in case of RC circuit, the voltage across R will lead the voltage across C by 90 degree, right? So the answer is C. Now we shall see one more question. Total current in an RC circuit always leads the source voltage. The given options are like this. A is true, then B is false. So the right answer is true because total current in RC circuit always leads the source voltage. In an RC circuit, the impedance is determined by both the resistance and the capacitance reactance combined. Yes, to calculate the impedance, we need the resistance value and also the capacitive reactance value. So it is true. Now we shall see the MATLAB script for the given exercise. So here I have just entered the given data like C, the value of capacitor and the value of resistance. So C is given as 10 microfarads. So that's what is shown here. Then the value of R is 10 kilo ohms. So now we need to enter those values in this program. Then the time constant of RC circuit is R into C. So that I have taken it as tau. So tau is equal to R into C. Then I am using a for loop here. ಇಲ್ಲಿ ಎಕ್ಸಸೈಜ್ ಅಲ್ಲಿ ಇನ್ಪುಟ್ ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ ಪಲ್ಸ್ ಆಫ್ ವಿತ್ 0.5 ಸೆಕೆಂಡ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ 0.5 ಸೆಕೆಂಡ್ ಚಾರ್ಜಿಂಗ್ ಪೀರಿಯಡ್ ಅಂತ ತೊಗೊಳ್ಬೇಕಾಗುತ್ತೆ. ಮತ್ತು ನೆಕ್ಸ್ಟ್ 0.5 ಸೆಕೆಂಡು ಡಿಸ್ಚಾರ್ಜಿಂಗ್ ಪೀರಿಯಡ್. ಸೊ ಅದಕ್ಕೆ 2 ಡಿಫ್ರೆಂಟ್ ಇಕ್ವೇಷನ್ಸ್ ಬೇಕಾಗುತ್ತೆ. ಅಂದರೆ ಡ್ಯೂರಿಂಗ್ ಚಾರ್ಜಿಂಗ್ ಪೀರಿಯಡ್ ಈ ವಿ ಐ ಆಫ್ ಈಕ್ವಲ್ ಟು ಅಂತ ಏನಂತ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಸ್ಟ್ ಫಾರ್ ಲೂಪಲ್ಲಿ ತೋರಿಸಿದೆ ಅದನ್ನು ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಬೇಕಾಗುತ್ತೆ. ವೆನ್ ದ ಕೆಪಾಸಿಟರ್ ಇಸ್ ಗೆಟಿಂಗ್ ಚಾರ್ಜ್ಡ್. ಡ್ಯೂರಿಂಗ್ ಡಿಸ್ಚಾರ್ಜ್ ಪೀರಿಯಡು ಆಗಲೇ ನೋಡಿದಾಗೆ ನಾವು ಇಕ್ವೇಷನ್ನು ಸಿಂಪ್ಲಿಫೈಡ್ ಇಕ್ವೇಷನು. ಸೊ ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರೋದ್ರಿಂದ ನಾವು ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ನ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಬೇಕಾಗುತ್ತೆ ನೆಕ್ಸ್ಟ್ 0.5 ಸೆಕೆಂಡ್ಗೆ. ಸೊ ಇಲ್ಲಿ ನಾನು 100 ಡಿಫ್ರೆಂಟ್ ಟೈಮ್ ವ್ಯಾಲ್ಯೂಸ್, ಅಂದರೆ ಯಾಕಂದರೆ ನಾವು ಎಕ್ಸ್ ಆಕ್ಸಸ್ಸಲ್ಲಿ ಟೈಮ್ ತಗೊಳ್ತೇವೆ, ವೈ ಆಕ್ಸಸ್ಸಲ್ಲಿ ವೋಲ್ಟೇಜನ್ನ ತಗೊಳ್ತಾ ಇದ್ದೇವೆ. ಸೊ ನಮಗೆ ಬೇರೆ ಡಿಫ್ರೆಂಟು ಟಿ ವ್ಯಾಲ್ಯೂಸ್ಗೆ ವಿನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ ಪ್ಲಾಟ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ. ಸೊ ನಾನೇನು ಮಾಡಿದ್ದೇನೆ 100 ಐ ಡಿವೈಡ್ ಬೈ 100. ಸೊ ಇಲ್ಲಿ 1ಇಂದ 50ವರೆಗೂ ತೊಗೊಂಡಿದ್ದೇನೆ ಐ ವ್ಯಾಲ್ಯೂಸು. ಇಲ್ಲಿ ಡಿವೈಡ್ ಬೈ 100 ಅಂತ ಹೇಳಿದಾಗ ನನಗೆ ಇಲ್ಲಿ ಸುಮಾರು ಪಾಯಿಂಟ್ಸು ಅಂದರೆ ಟಿ ವ್ಯಾಲ್ಯೂಸು ಸುಮಾರು ಸಿಗುತ್ತೆ. ಸೊ ಅದು ಎಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್ಗೂ ಆ ಎಲ್ಲ ಟಿ ವ್ಯಾಲ್ಯೂಸ್ಗೂ ಕೂಡ ವೋಲ್ಟೇಜನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ಬೋದು ಈ ಎಕ್ಸ್ಪ್ರೆಷನಿಂದ. ಸೊ ಇದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಇಲ್ಲಿ ಇದು ಚಾರ್ಜಿಂಗ್ ಪೀರಿಯಡಲ್ಲಿ ಆಗಿರುತ್ತೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಹಾಗೇನೆ ನಾವು ನೆಕ್ಸ್ಟ್ ಮಾಡ್ಕೊಳ್ಳುವಾಗ ವಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಏನು ಬಂದಿದೆ ಅದನ್ನು ತಗೊಳ್ಬೇಕಾಗತ್ತೆ. ಸೊ ವಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ವಿ ಆಫ್ 50. ಅಂದರೆ ಲಾಸ್ಟ್ ಪಾಯಿಂಟ್ ಇಲ್ಲಿಂದ ಬಂದಾಗ ಲಾಸ್ಟಲ್ಲಿ ನಮ್ಗೆ ಏನು ಬಂದಿದೆ ಅಲ್ವಾ 50 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ ಆಗ ಏನು ಬಂದಿದೆ ಅದನ್ನು ಆ ವ್ಯಾಲ್ಯೂನ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕಾಗತ್ತೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ವೋಲ್ಟೇಜು. ಆಮೇಲೆ ನಾನು ನೆಕ್ಸ್ಟು ಹಾಗೆ ಫಾರ್ ಲೂಪಲ್ಲಿ ನೆಕ್ಸ್ಟ್ 0.5 ಸೆಕೆಂಡ್ಗೆ ನಾನು ಡಿಫ್ರೆಂಟ್ ಟಿ ವ್ಯಾಲ್ಯೂಸ್ ತಗೊಳ್ತಾ ಇದ್ದಾನೆ. ಹಾಗೆ ಅದಕ್ಕೆ ಅದನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ವೋಲ್ಟೇಜನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ದಾನೆ. ಸೊ ನನಗೆ ಡ್ಯೂರಿಂಗ್ ಚಾರ್ಜಿಂಗ್ ಪೀರಿಯಡನ್ನು ಎಲ್ಲನೂ ವೋಲ್ಟೇಜ್ ವ್ಯಾಲ್ಯೂಸ್ ಸಿಕ್ಕಿರುತ್ತೆ. ಹಾಗೆ ಡಿಸ್ಚಾರ್ಜಿಂಗ್ ಪೀರಿಯಡಲ್ಲೂ ವೋಲ್ಟೇಜ್ ವ್ಯಾಲ್ಯೂಸ್ ಫಾರ್ ಡಿಫ್ರೆಂಟ್ ಟೈಮ್ ವ್ಯಾಲ್ಯೂಸ್ ಅದ್ರಾಗೆ ಟೈಮ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿಕೊಂಡು ಆ ವ್ಯಾಲ್ಯೂಸ್ ಬಂದಿರುತ್ತೆ. ಸೊ ಅದನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಪ್ಲಾಟ್ ಮಾಡ್ಬೋದು. ಸೊ ಐ ನೀಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ voltage values for different instant of time. So for first 0.5 second, okay, that is a charging period. So for first 0.5 second, I am using this expression, the first which is there in the first for loop. So this expression is used to calculate the voltage values. And then next, for the next 0.5 second, I am going to use the next expression which is shown in the second for loop. Okay, since I need to calculate for a different instant of time, I am going for a for loop. So it's going to start from 1, and this first for loop, it's going to start from 1 and it's going to go up to 50. So for all those values, I'll be getting the voltage calculations done. So I can use those values for plotting the graph. So for plotting, I'm using the command plot t comma v, because I need to take time on x-axis and voltage on y-axis. And here I'm going for changing some of the characteristics. So I'm making use of the set command. So set, and then I'm choosing the color as red. Then line width also is changed to 2. Okay, then I need to mention the axis details. So here I'm going for 0 to 1 for x-axis, and then 0 to 6 for the y-axis. So by using this axis command, I can mention all those, I can give all those details. So I'm entering here 0 to 1 for the x-axis and for 0 to 6 for the y-axis. Then I need to put a title for the plot. So I'm using the command title, and within single quotes, I'm just mentioning the title. So a text has to be put here. So this I'm going to get it as the title. When I execute the program, it's going to be displayed on the plot. Then I'm using the command x label to put a label for x-axis. Then I'm using the command y label to put a label for y-axis. Then I'm using a text command just to display the value of resistance, and one more text command to display the value of capacitor. Here I'm mentioning the coordinates also, x and y coordinates. So x is 0.7, y is 2. So in the graph where x is 0.7 and y is 2, the text will be displayed. I have entered the same program in MATLAB. So initially there has to be statements to show the values of capacitor and resistor. Then I've included the calculation part. So this calculates tau equal to R into C, calculates the time constant. Then I'm calculating the voltage values. And then plotting is done. So when I run this program, I'm going to get the graph like this, plot like this, with all the details like title, X label and Y label. We shall see a multiple choice question now. Time constant of RC series circuit is L by R, 2RC, 2L by R, RC. So the correct answer is RC. What is the expression of the current in the RC circuit? So here again you have 4 different choices. So the correct expression is I is equal to V by R to e to the power of minus t by RC. So C is the right answer. What is the default increment value in a for loop? It is 1. For loop default increment value is always 1. Which of these is the way to access the first element in a vector named V? Assuming there is at least one element in the vector. So how do we access the first element in a vector named V? That is V of 1. So the correct answer is B. Then Y label of text labels the Y axis of the current axis modifies the label appearance. Which of the statement given above are correct? 1 only, 2 only, both 1 and 2, none of the above. See here, the right answer is 1 because it labels the y-axis of the current axis. To modify the label appearance, you can include these uh, keywords like font size, color and all. Okay, and we can also mention the value for those properties. Font size is 12 here, then color is red. So here right answer is only 1. A. Then what is the output of the following code? V is equal to 10 E plus 02. The correct answer is 1000. So we saw the MATLAB script for the RC circuit. Then we also saw few multiple choice questions in this session. That's all for this session. Thank you.